Okay, this session we're going to go ahead and we're going to test the evaporation system to see if we can coat a glass tube envelope with aluminum. Okay, first let's look at the equipment. We've got our high vacuum system. We've got the mechanical pump, which is a 15 cubic foot per minute unit. It's a Welsh two-stage. I put a DC motor on it. The pump originally comes with an AC motor. It runs at 1750 RPM all the time, makes a terrible amount of noise, gets hotter and all get out, wears out quick. You know, you take that motor off and put a DC motor on it, and you can run it at variable speed, slow the speed down to what you need, and the pump runs very cool, uses very little electricity, and it doesn't make a lot of noise. Okay, we have an isolation solenoid, so we can leave the system under vacuum if we want. Right now we have it open because I'm going to show you the various parts inside of it. Okay, we have a barometron that's used for measuring our roughing pressure. This is a 1 torr barometron. Very easy to use. It puts out 0 to 10 volts for 0 to 1 torr. And we just take that and we feed it into a digital meter, and it reads out directly in microns. So right now we're at atmospheric, so it's at full scale. All right, we have, for generating the vacuum, the high vacuum, we have a turbo. This is a 160 liter per minute turbo. If you look at my other videos, you can see how we rebuilt it, and it's working beautifully. This one pumps down to 10 to the minus 5th torr in about 5 to 10 minutes, which is working great. And this is the one that has the missing third stage in it. Didn't put the third stage back in because it was damaged. To cool the turbo, we have a muffin fan. This is a high-speed muffin fan that has plenty of air to cool it. The turbo normally does not need water cooling if you're not going to use the heating jacket. There's a heating jacket that goes on it where you can bake out the turbo, and you don't need to use the water cooling if you're not going to bake out the turbo. And for all the stuff that I'm doing, I don't need to bake it out. Now, for running the pump, the mechanical pump, we have a DC power supply that puts out 24 and 40 volts. 24 volts for the low speed and 40 volts for the high speed. And we have just a simple switch that selects low and high speed. That way we can either run the pump fast to get it pumped down quick, and then once it's pumped down we can put it to low speed and it just pugs away there. It'll just sit there all day long and be very efficient, low noise, and very low wear on the pump. That pump will last for 20-30 years, just like the old Welsh mechanical belt-driven pumps. Okay, here we have our turbo controller. This is the home-built one. I'll have plans for it on my website soon as I get some time to put the plans together. And this is a home-built turbo controller to run the turbo. And to generate the heat for the evaporation, we have a very high current transformer. This transformer is this transformer is actually a 2 kilowatt transformer, even though it's only driven to 1 kilowatt. It's capable of 2 kilowatts, but the variac that I'm driving it with is only a kilowatt variac. So we're only using it to half its capability. It puts out a total of 5 volts at approximately 250 amps right now. So it's capable of more than that, but all of the evaporation sources that I've looked at, 5 volts at 200 amps will operate them. Now, to measure the high vacuum, I have an ion gauge. I don't have this hooked up. I already know the thing goes to 10 to the minus 5th torr, so there's no reason to hook up the gauge tube right now for this test. But normally I will have it hooked up. All right, now, here we have our evaporation source. Okay, we have one connection here which goes to the case of the bell jar, and we have our connections here to where we have one of them going to the case. This is our 5 volts at 200 amps. And we have the other one that goes to this high vacuum feed through. It's insulated carefully from the case for our 5 volts. And therefore we have our 5 volt power on this big stud here. So we have our evaporation source. Okay, we have a strip of molybdenum ribbon. This is about a 1/2 inch wide and maybe 2 inches long. And in the middle we can see the aluminum. I've already heated it up, and the aluminum is melted into a little pool in there. That's aluminum that has been melted. It's just a couple of little pieces of aluminum shaving. And that's what we're going to use to coat the inside of the vacuum tube. Okay, now the tube we're going to do, this is just a test. I have an old envelope here off of a tube, and we'll go ahead and we'll coat the inside of it with aluminum to make it shiny. This is just a test. I've never done this before, so this is all new to me. I'm just doing this experiment here. Now to hold this, I've just taken a little piece of wire and bent it to where it'll hold the envelope right over the evaporation source. So as it evaporates, it'll go up inside the envelope and coat the inside. I've carefully cleaned the inside of the envelope with steel wool, so it's all clean. Okay, now the next thing we have to do is put the bell jar on and pump it down. Now I've already put some vacuum grease on the rubber gasket. Now when you put the bell jar on, you carefully center it so that the glass itself is not touching metal all the way around. You want it to be sitting only on the rubber gasket. If it touches metal, then you can get a stress point which will potentially cause a crack in the glass. So you very carefully center it on the gasket so you're not touching any of the metal. Okay, now we turn on the pump, and it's a pumping down. Okay, we'll let that pump. Doesn't take long. I'll go ahead and put a muffler on that thing when I get a chance. Okay, we're now down to about 10 torr. It's going down fast. There she goes. 11, 10, 900 microns, 800. These are microns now. We're going that fast on that big bell jar. That huge 15 cubic foot pump takes her down quick. 400 microns. Okay, we're well within the pressure range of the turbo. The turbo can be started anytime the pressure is below about 500 microns. So normal operating pressure for the turbo is 50 microns or less. So what we'll do now is we'll switch on the turbo and we'll let it come on up. And by that time, the pressure, the backing pressure, will be down in below 50 microns where the turbo runs. It takes about 5 minutes for the turbo to get to full speed. Okay, we've been pumping for about 15 minutes now. We have 2.2 amps running through the turbo, which is well below the 3 amp rating. And our speed is at maximum speed, and we're running 34 microns on the backing pressure. Now we can tell that we're pumped down in the chamber because When the turbo is speeding up, beginning to pump, the backing pressure will rise. It goes up to 50, 75, sometimes even to 100 microns for a few minutes. And then as the turbo pumps down the gas, the pressure comes down. The load on the pump decreases, so the pressure goes back down to its stable value. About 33 microns is about all this pump will do with this kind of a load on it. So we're now stable. The vacuum in the chamber is now in the order of 10 to the minus 5th torr. This is just perfect for doing the evaporation. Okay, now, I'm going to bring the temperature up. I'm just turning the variac up on the evaporator. There she goes. Okay. You can see it evaporating. All right. It doesn't look anything like what I thought it would. Oh my gosh. I'm going to have to do some studying on that. The top looks a little bit shiny. Okay, I'm going to go ahead and shut the turbo off. We'll just let the turbo slow down, go off, and then we'll open it up and take a look at what we've done. Alright, our pressure's equalized. Let's just go ahead and we'll take the bell jar off. That doesn't look like what I thought it was going to look like. It should be a shiny aluminum color, but it looks kind of cloudy and black and yucky. So this is going to take some experimenting. It's on there good though. I mean, I can't, I'm scraping my finger. You can see my finger there where I'm scraping it. It's on there good though. It feels pretty good. Now on the bottom here it's not. There I got some of it off. Here's some of the plating right here. Down at the bottom where I didn't clean. And it kind of flakes off right there because I didn't clean the bottom. I just cleaned up inside there with the steel wool. But this should be all shiny. I want it to be shiny like aluminum, so I'm going to have to do some experimenting to find out what it takes to do that. Okay, let's try doing one this time with gold. I have here a small piece. It's a coin of some kind, a very small coin. It's supposed to be 24 karat gold, pure gold. And we'll go ahead and we'll see what happens when we try using that to make some plating. Okay, now we'll get rid of our aluminum one here. That's actually, see, we got a hole in it. It was eating through. Aluminum dissolves tungsten or molybdenum or whatever this stuff is. Okay. That gets our little evaporation boat in there. Now we're going to take our little gold coin and we're going to put it right in the middle where the dimple is, and then we'll seal her up and pump her down again. that'll be a good one. We're going to put the piece we're going to coat in there. Here we have another piece of an old tube envelope. This is an old tube. It was no good. And I just got the envelope off of it. And we're going to coat that with gold on the inside. So we're going to hang that in there so that it sits right over the evaporation source. Two. Oh, that's good enough. I mean, it's just an experiment. We don't need it precision. If we're going to do something precision, we'll get some precision mounts made up. Okay, let's go for it. Okay, we'll go ahead and pump her down, get the turbo going. Okay, we've been pumping for about 10 minutes now. We're down to the correct temperature, pressure on the roughing, and we got the correct current on the turbo. Okay, now, the first thing we have to do is we got to melt the gold. Okay, now, I'm going to run the current up. And we're going to melt the gold into the little puddle there on the heating element. Okay, see the gold is melted now? It's no longer a coin. Okay, now we're going to heat it up and we're going to try to evaporate it. Okay, it's doing. Once again, we get black. I don't understand it. All right, turbo off. Okay, we'll let her slow down and we'll see what's going on. All right. Look how beautiful that is inside. You can see how the gold is inside? That's just beautiful. But look at the outside. It looks black. Doesn't have a gold look on the outside. Boy, the inside is just gorgeous. What I'm suspecting I don't know exactly. See the gold on there? Just clean as can be. What I'm suspecting is some of this metal on the evaporating thing is evaporating. I just wonder if that's really the type of metal that I think it is. It may not be molybdenum. It might be ordinary steel or something like that. And it might be evaporating. What I'm going to do, I'm going to put a piece of that steel in there with nothing on it and see whether it makes a black coating. Okay? Okay, we're pumped down again, and turbo's been running for about 10-15 minutes now. Now this time we've got just a plain strip of the metal in there. You know, it's only the metal, the base metal itself. We don't have any evaporating material on it. And we're going to see whether when we heat that up, if it makes that black stuff. There's something making that thing black when we're doing this evaporation, and we're going to try it now using that. Wow, pressure just shot up to 45 microns. Just let it outgas a minute here. Okay, now we're heating it up again, and we don't have any pressure increase, so the turbo's taking it out. Now I'm going to take it up to evaporating temperature, and we'll see if we get any now that's just the plain evaporation material itself. Nothing evaporates off it. So it's pretty clear we got something else that's causing that black. Okay, that's it for this experiment. I'm going to have to do some research to find out what's causing that black.